Alright, we're live. Hello everyone and welcome to yet another authorizing session. Hello, welcome. Let's make a little bit of an announcement and officially start the stream. So, we're gonna do live, red circle, yeah, I forgot. Live on Twitch, and what are we doing today on Twitch? Today we're doing 3D in C yet again, and I'm gonna give the link to the Twitch chat. Where we're doing all of that, and I'm gonna ping everyone who's interested in being pinged. There we go, the stream has been officially started. So what we're doing today, we continue developing Olivet, which is the graphical library that we've been developing for quite some time, I think like 3 or 4 months already. You can find the source code in here if you're interested. I'm gonna put that thing in the description as well, so here you go. So it's a very simple graphical library that is rendering everything into the memory, right? It is not concerned with how to display what it's rendering, it just fills up the memory that you allocated, right? So you allocate the memory, you give the library that memory, you ask the library to draw something in there, and it draws something there, and then you do whatever you want with that drawing. So that's basically the library, and you can do all sorts of things. There is a demo website on the GitHub page, and this is kind of things you can render with this thing. You can render rainbowish triangles, circles, semi-transparent circles. As you can see, it have gradients, it supports transparency and stuff like that. So we have a little demo that you know, draws some dots in a 3D space and projects them onto the screen, and you have this little nice cube. Right, so we also have some sort of a texture resizing with bilinear interpolation. As you can see, there is a smooth interpolation, no pixelation whatsoever, right? So we have a little bit of a 3D, right? So with shading and stuff like that. So the library allows you to do barycentric coordinates, which you can use to decide to actually calculate the depth of your object, so you can actually shade it in a particular way. You can also rotate textures, you can actually put textures in here, and so on and so forth. We have a lot of examples, and all of that is rendered on CPU pixel by pixel into memory, without any OpenGL, without any Vulkan, without anything. It's just pixel by pixel on CPU. Right, so this library is concerned with portability, it's concerned with simplicity, it doesn't go for speed, right? So it goes for portability and simplicity, right? So even though it doesn't really go for speed, this is rendered on CPU, and this has like 6,000 triangles, or I don't remember. I think it has like 6,000 triangles, and it's not running with 1 FPS, which is really kind of cool, I think, on a 10-year-old laptop from which I'm also streaming, right? So keep that in mind. So considering all of the weird and questionable technical decisions that we made about this library, this should not work, like, at all. This should not work, like, it shouldn't even show anything. It should be so goddamn slow, it's impossible to use, yet it is doing things, which means that computers are much faster than we think they are. You just need to remove a lot of crap, right? If you remove a lot of crap and you just like strip it down to bare bones, they actually surprisingly fast without you doing much, which is weird, isn't it? Right, so anyway, so what I wanted to do today, so we needed to implement near and far clipping plane, right? So we do a little bit of a projection, right, in 3D space, and Z is actually going from 1 to 2. Okay, so I think I need to actually start my paint and actually bust out my tablet. Okay, so we can actually show what exactly we're doing. Alright, so imagine, so we're looking from the side, right? We're looking from the side. That means Z is going to the right in here, right? Let's imagine that Z is going to the right, so this is Z. And here we have Y, right? So this is Y. Our eye, when we are projecting everything, our eye is located at 0, right? At Z0, so this is our eye. I wish I could actually spell it a little bit more nicely. So the screen is located at position 1 of Z. So if you put it like that, this is a screen. So, and then we have like a limitation to 2 in here, and our object is usually located in here. And what we effectively do when we're projecting that object onto the screen, we just basically draw these two lines, right? And now we know the boundaries of this object. We projected the points of this object onto the screen, and this is what we actually draw on the screen. So this is how basically projection works. All right, and essentially, we want to keep our objects inside of this specific range. Right, we want it to be inside of this specific range. If the object goes somewhere, for example, like that, maybe I actually want to make it a little bit brighter and something like this, right? So we want this part to be cut out. So this is what's usually done in OpenGL. There is so-called near clipping plane, right? So we can say that this specific screen is not only a screen, but it's also sort of like a near clipping plane, near clip, right? And we can also say that this is going to be far clipping plane, right? And everything that falls behind any of these clipping planes, it should be illuminated, it should be not drawn, right? So, and the question is, what if you have a big scene, right, that is much bigger than one? Right, you have to basically, you know, take your scene and project it so it's within these boundaries. So this is how it's usually done. I'm not sure how exactly OpenGL works. Maybe it's actually configurable, so you can actually decide where those planes are located. Maybe we can do that as well. But just for the sake of simplicity of the math, it's just easier to do it like that, right? So this is one of the things we wanna have. And the reason why we wanna have that is because if your objects, like these objects, are too big, so big that, for example, a handle starts to poke out of the screen, right, we're starting to have a lot of weird behavior, right? So to avoid that weird behavior, we want to kind of like cut everything that goes behind the screen, and, you know, just for the symmetry, we also want to do the far clipping plane that cuts everything that goes too far, because why not? Maybe like far clipping plane in our case is not particularly necessary, but the nearest one is very important, because I'm going to show you what's going to happen if you don't do that. All right, so let me take a look. So I'm gonna open Olivet, and so I think I want to rebuild. I think I already rebuilt all of the demos, so I don't need to do another rebuild. So this is the demos, and let's take a look at the Teapot SDL. So here is the SDL version. This is the native version without any web bullshit, right? So it works without browser. Imagine like an application working without a browser in 2022. It's unimaginable these days, right? It's a lost technology. Nobody's doing it like that. So, and let's actually open the build script. So we have a function that builds the assets, right? And within the assets, we basically take the object file, right? The Utah Teapot. So here is the thing, and we're converting it into a C code, so we can include this object into our C program, so it gets baked into the executable. So you don't have to think about how to load this object, and if you're on the web, you don't have to think how to query that object over HTTP. It's baked into the executable. You don't have to worry about that. So we basically bake everything. It's pretty convenient, but the utility that we use to bake the 3D objects into the executable, it has a very interesting flag. It allows you to scale the object, right? So because the object too big, it doesn't really fit into the range from 1 to 2. We want to scale it down a little bit so it fits there and doesn't produce weird result. So if we make it a little bit bigger, if in fact we can pick the original scale, right, 1. So what was the original size of the object? So let's try to rebuild that specific demo. So I'm going to rebuild demos, and specifically I'm going to rebuild, I think I need to rebuild like all of them, because I need to rebuild the assets, right? So let's rebuild the assets. The assets has been rebuilt. So look how much time it takes to rebuild the assets, right? It's just so fast. Look at that. Right, it's less than a second, less than 100 milliseconds. We took all of the images, all of the PNG images, and all of the object files, and we generated C code out of them so we can bake them into our programs. And it was just like super fast. It's kind of fun. Anyway, so let's actually now rebuild the demo. The demo that I want to rebuild is a Teapot3d, and I want to rebuild it for SDL specifically. So I'm going to actually be very specific so we don't waste too much time. All right, and let's do build. demo Teapot3d SDL, and so as you can see, it starts to lag a lot, and we're inside of the yeah, this is actually kind of cool. As you can see, so there's a lot of weird behavior if you don't cut you cut your polygons to the clipping planes. So it gets even more weird, I suppose, if we just make it a little bit smaller, so you can see the moment when it gets really weird. Alright, so let's actually rebuild the entire thing. I wonder if we can just do assets, right, and then just no build demos Teapot 3D SDL, and then run build demos Teapot SDL. You probably can't see everything. Yeah, well, you can see something, which is nice. Okay, sure. So as soon as it sort of hits the handle, it gets really weird, and it gets also super slow. Yeah, as you can see, that's basically what's happening. Right. Yes. Actually, it's not that bad if you think about it. So, I mean, visually speaking. So if I make it slightly like 60, I wonder how it's gonna behave. Okay, so it works nice, and as soon as the handle sort of hits the camera, we're starting to get like all of this weird behavior that is actually some of the things. Look at that. Some of them are starting to even cross through these things, so it's definitely not correct. Some of the math doesn't work out. You see, we're starting to get these huge things, and I wonder like where exactly all of that starts to happen, right? So this is basically the problems that we have, and it's also super slow. So maybe there's some sort of like a none in the coordinates somewhere, but this is exactly what we want to explore today, right? So this is precisely what we want to explore today. So that's the topic of today's stream. Okay, we got some subs. Thank you so much, and Shay, for 2 months of tier 1 subscription. Thank you, really appreciate it. Hello everyone. Welcome. How are you guys doing? Alright, so yeah, that's basically the plan for today. So I accidentally saved the compilation thing, I don't know why. Okay, and the same thing we kind of have with the cup, right? So we have a demo that demonstrates a cup. So let's take a look. So this is a Cup3d SDL. It works fine if it doesn't clip, but if you make it clip, it's gonna get really weird. So let's take a look at the source code of the demo. Right, so here's the Cup3d, this is for the cup, and we also have a Teapot 3D. So the implementations of these two demos is rather interesting. So if we take a look at the implementation of Teapot 3D, it looks like this. It's literally 3 lines. Right. And if we take a look at the implementation of the Cup3d, it's 2 lines. So these two demos, right, these two demos, if we go in here, their implementations are like 3 and 2 lines. So we just include a bunch of files in here. And here is an interesting thing. So the main demo is model 3D. And model 3D, when it renders its model, right, when it renders its model, it looks for global variable vertices and faces. And those global variables are generated by the asset generator. Right, so if you take a look at, for instance, cup, right, cup, low poly, I think that's what we need. Yeah, there we go. So here's the vertices, and down there we have faces. Right, so essentially, model 3D doesn't care about specific model it's rendering. It just expects to have a global variable vertices and a global variable faces. That's it. Right, so it finds those and it just renders whatever in those global variables. Right, and those global variables are defined in different files. So if you want to have a demo with a specific object model, right, so in this case, what do? So Cup3d, we just include the cup model, right, which imports the vertices and faces, and then we include this thing, which also includes the entry point and stuff like that, and there we go, we're good to go. You want a different demo, you just include a different object in here, and it's gonna be the same code, right? Look at the reusability of this code. Look at the reusability of this code. We're not using any fancy abstract factory bin visitors pattern or anything like that. This is literally a concatenation of two files. And look how much flexibility you can achieve through just concatenation of two files without any ideological OOP FP bullshit, just by concatenating two files. Isn't that amazing? I think it's freaking amazing. People spend years studying different patterns, reading and writing shit ton of books on OOP. I'm sorry for my French accent, for an OOP and shit like that, just to end up with somebody who programs in C to beat them up at the level of flexibility. It's just like, yeah, I just include, like, I can just substitute, like, can your dependency injection do that without thousands of lines of XML? Well, it's kind of like a dependency injection, basically. Anyway, whatever. All right, so let's go. Anyway, so this is basically, I was explaining how exactly these 3D demos work, right? So basically, Cup3d and Teapot3d are literally the same code. So this is kind of important for our case, because we're going to be fixing both of these things simultaneously, right? So I'm not working on the code of any of this specific demo. They share the same code, right? They share the same code. All right, so model 3D. Okay, so how do we do all of that? So we iterate through all of the faces, right? Then face is just an index within the vertex array, right? We get the corresponding vertices and we take their points in 3D. Right, we take their points in 3D. One of the things we do, we add to the z value of all of these points 1.5. Who knows why? Why do we need to add 1.5? Remember that we're projecting the things that are between these values, 1 and 2. It doesn't really necessarily have to be between 1 and 2, it's just like we set up the math, so we kind of expect them in this specific place to be between 1 and 2. You can set up math in different ways, and it's going to be different values. It doesn't really matter, it's just the details, right? It's just like we set up the math, so we have to put these things between 1 and 2. Right, the next thing we do, then we project this thing onto 2D screen, and as you can see, we have 3 points, but 2D. We had 3 points in 3D, and now we have 3 points in 2D. We destructurize them, so we can have separate variables, because it's easier to put them into the olivets. And then we normalize a triangle. Normalizing a triangle is essentially finding its boundaries, finding the rectangle on the screen that surrounds the entire triangle. So we can iterate through each individual pixel, and then we have a way to check whether the pixel that we're iterating is within the triangle or outside the triangle, right? We use barycentric coordinates to determine that, right? So, and through the barycentric coordinates, we can actually take the z values of each individual point and interpolate them to know the z value of the pixel of the triangle that we're actually rendering right now. And since the z is projected, the z value is projected, it's actually distorted because of the projection. So we cannot interpolate z directly. We have to take inverse value of z, 1 over z. We linearly interpolate 1 over z, and this value is actually 1 over z, not z. It's 1 over z. Then we use a little bit of the z buffer to know whether we want to render something or not. Then if we actually found something that is closer to us, we render that specific pixel. We also store that pixel in the z buffer. We also mix the colors, and then we use that value for the shading, right? So if the pixel is too far away from us, we color it a little bit more darker. If it's closer to us, we color it more brighter, and this is how we achieve this a little bit of a shading. I'm not sure if it's easy to tell, but you can tell it when the handle is actually like a little bit far away. You can clearly see that there's some sort of a shading going on in here, right? So it's clear that there is some sort of a shading. It's not super obvious, but if you look closer, yeah, so the farther away the pixels, the more darker they are. So I think it's a little bit easier to see with these kind of textures, right? So that's basically the situation in here, right? And this kind of setup makes it kind of obvious how to implement the near clipping plane, because we're rendering each individual triangle of the model pixel by pixel, right? So all of that stuff is rendered pixel by pixel, and we have loops. We have loops that iterate through each individual pixel, so we know the values of the pixel, we know the coordinates of the pixel, right? We know the coordinates of the pixel. And so what's interesting is that we can now start computing the near clipping plane, right? We can start computing the near clipping plane. For instance, since we know the z, we can literally check if the z turned out to be too close, right? If it turned out to be too close, we just don't render that pixel. We can try to do something like that. But here's the problem. Z is inverted values, so that means we have to invert it back. So we kind of already inverted in here, but I mean, it's just like it needs a little bit of refactoring. So, and now, one of the things we probably want to do, we want to check if it's less than 1, right? If it's less than 1, we probably don't want to even render this entire thing, right? We probably don't want to even render it, so I'm going to just like wrap this entire thing in a condition, and we'll try to see if everything is okay, right? So there we go. So let's actually rebuild this entire thing. Let's rebuild this entire thing, and there we go. Okay, so let me see. It's going to be build demos Teapot3d SDL. And does it really fix anything? And you know what's interesting is that it doesn't really fix anything, right? So, and this is one of the reasons I want you to stream today, because this idea of just clipping it like that doesn't really work, because as you can see, the situation we get is that the points are going somewhere into the infinity, which indicates that there's some sort of a situation that turns some of their values into none, probably. But we don't really know for sure, right? And so this is something that I really want you to explore today, right? So spend some time maybe writing some tools that let us to capture all of the current values of the things and stuff like that, and just explore what exactly going on. Because with this kind of code, setting up like near and far clipping plane should be straightforward. You have the z values of the pixels. Right, just check that they are within the range and you're good to go. Right, so they should be like disappearing, but they're not for some reason. So it's kind of weird. Something is really fishy going on here. If I remember correctly, it kind of works for the far clipping plane. If you say that, okay, if it's bigger than 2, it will actually cut them off. But we'll have to go back into the I think it was like around 4, right? I think it was around 4, so let's actually see. Let me rebuild some of this stuff. No build demos Teapot3d SDL, and let's actually try to do this kind of thing. Okay. Something is even more funnier than it is, but yeah. Alright, so this one is greater than that. Let me disable that and just see if it worked as it was before. Okay, so yeah, I didn't rebuild the assets, right? So I'm supposed to rebuild the assets. So let's also do that. Okay, so now it works. And let me go to here. So it's something like model 3D. Let's bring this entire thing back. And there we go. Huh. What's interesting is that it feels like it's working like a near clipping plane, you know? Maybe we should not invert this entire thing, right? Because as you can see, I'm inverting this entire stuff. But we're supposed to invert this thing because it is inverted, right? Because you cannot interpolate not inverted things. So there's something a little bit sus in here, for sure. Okay, I'm gonna try to not invert that and see like what exactly going on in here. And it's completely okay. So it kind of works, but it's a bit weird. All right, what if I increase this by 2? So it works completely counterintuitive for me. You know what I mean? Aha, so that means it has to be smaller. It has to be smaller. All right, the smaller this thing I make, the more weird it becomes. What if it's 0? Okay. So, and this is exactly what I want you to do today. I want you to explore what the hell is going on in here exactly, because it's kind of weird. For instance, one thing I would like to do is to inspect the Z buffer, right? So, because it's not really intuitive for me, what are the values of the Z buffer and how all of that works, right? So, yeah, so one of the things we can try to do, we can try to write a tool that allows us to stop the animation and just find the smallest Z value and the biggest Z value, or something like that. So it sounds like a good idea. Or maybe even, that's a cool idea. Basically click on the screen and it will tell us the Z value of that specific thing in there. That's actually kind of cool. Yeah, it's basically like printed somewhere to the STD out, if you know what I mean. Right, so that sounds like a pretty cool idea. Okay, so let's actually start working on that because I really want to understand what is going on in here, right? So let me see, let me actually disable this entire thing. And let's go. Okay, so I didn't mean to actually put it in here. Cool. So let's go ahead and try to do that. Some of the things I need to do. I need to be able to interact with the demo. So the problem with the demos right now is that I can't really interact with them apart from making them pose. But pose is a feature of the framework that this entire thing is using, right? So it's a feature of the framework. We want to probably extend that framework. We want to extend that framework to maybe handle the keys, right? When the user presses the key, we want to pass those keys to the demo, so the demo itself can maybe handle them and do something about them. All right. So let me reverse this entire thing, and so what we can do: VC key, maybe key down, right? But maybe we can also have something like event. Don't really want to introduce the entire framework just for that. That would be kind of weird. Matewsef777, thank you so much for tier 1 subscription. 48 months of tier 1 subscription. Holy shit, that's a lot. Thank you so much. Right, so let's actually do key down. Alright, and in here we're gonna actually accept the key, which is gonna be probably ASCII. And I think that's gonna be enough for now. And we'll see how it goes. Right, so we have, I remember that we had like a forward declaration in here, so we can put forward declaration here as well. Key down, int key, there we go, right. So essentially, we're gonna add support only for SDL because that's the only platform that I care about right now. So for the terminal, it's kind of, I don't think I'm gonna add it to the other platforms because if I'm gonna, it's only needed for debugging, and I usually debug in the SDL platform, right? So all of the other platforms are just for the demo, right? So they don't really need to handle any of that. So let me find the platform, maybe VC SDL platform, right? VC SDL platform. Where do we handle all of that? There we go. So if we do key down, so we pause and pause, which is fine. So, but maybe on top of that, we can do something like VC key down, right, VC key down, and we can put a symbol in there, But the problem here is that the symbol is not particularly ASCII, right? So it is not very much ASCII, if I'm not mistaken. We can always like test it out quite easily. So we can just do printf, right? So we can do something like this, right? And then something like key down. This is the integer and this is the key, right? So it's gonna be so what do we do? Okay, so that's fine. This is a fine compilation line. All right, so yeah, that's kind of weird. Okay, so when I press space, it's 32, which is fine. I know that capital E, okay, it also handles shift. E, capital E, it doesn't really care if it's E or capital E. Right, so I'm gonna take a look at ASCII code. Right, so let's take a look at ASCII code. 101 is, it's an octal, but I need a decimal. So decimal, it's actually small e. And I was also holding shift, so it really didn't care whether it's like capital E or not capital E. It really didn't care. Okay. So what can we do in here? So it doesn't really matter that much, because what if I want to extend it in the future to work in other platforms, and other platforms have different schemes of indexing the keys and stuff like that. So I want to kind of limit this entire thing to ASCII, right? So I want to kind of limit it to ASCII. And one of the things I can do in here is probably just like literally check if is this thing an ASCII, right? Is this thing an ASCII? And in ASCII, as far as I know, we have displayable characters starting from 32 if 32 less or equal x and x is less. So the last displayable one is 126. Right, we can say 127, right? And if it is, we're gonna pass this entire thing in here, right? So we're only gonna pass this kind of stuff there. Right, and what's interesting is that that kind of does not allow us to have shifts, right? So if I press the shift, it just like doesn't, doesn't affect anything. We can even check how that specifically works. Where is my model 3D? Here is the model 3D, and instead of the integer, we're gonna do character, right? So this is the character. So let's take a look one more time. Right, so this is J. If I press shift, this is still smaller J, right? But if I port that to the terminal in the future, the way we handle that in the terminal, we're gonna have a like a capital J. So this one is not particularly a great way to handle all of that. So maybe we could use something like SDL text, right? SDL text, or maybe I shouldn't care because it's just like for debugging. So I think I'm spending too much time on this thing that is not particularly important, right? And anyway, what I want to do, I want to be able to, for instance, if the key is equal to something like S, just do the statistics of like what's going on, right? So for instance, we render into the Z buffer, right? So we render into the Z buffer, and where do we even clean up the Z buffer? Okay, so the Z buffer is cleaned up at the beginning of the frame, right? It's cleaned up at the beginning of the frame. And as far as I know, keys are handled before rendering the frame. So in here, we'll still have the Z buffer of the previous frame, so we can take some statistics of that buffer. For instance, we can just calculate the minimum and maximum value, right? So float means and max means, if I remember correctly, it's something. We can take the maximum of the float, FLT max, right, and then we can tell FLT minimum, right. I don't remember if it's like that, right, so the compiler will tell you. So, and then we want to iterate like each individual value of the Z buffer. Just I want to see what's the minimum and maximum just to get the gist of what's going on in here. Right, so something like this. So means is going to be, let's put it this way, if means is greater than Z buffer I, that's the new minimum, right? So that's the minimum, there we go. So could replace min, max, boom, but we have to change the this thing in here, there we go. And after that we can just simply print this entire stuff, right? So let's just simply print There we go, printf, and means is that. So this is going to be means, and this is going to be max. There we go. All right. So it's, well, I mean, it has to be within the pressed key, right? So it has to be within the pressed key. All right. What else do we have? Okay. So cool. I can pause, and I'm going to press S. So, and this is where it's very interesting, right? So the maximum Z is 4. Even though it's sort of like inverted, right? So that's what it is. Huh. If I put it like this and I take statistics, so yeah, it's from 0 to this. Okay, that's cool. So we can see some information in here. And now we can try to go ahead and make this thing bigger and just inspect minimum and maximum value of Z when we start to glitch around a lot, when the things that go out of the bounds and something really weird is going on, right? So we can now have an opportunity to do this kind of stuff. Okay, so I'm gonna actually pause. So we paused, and then I'm gonna take the stats, and this is really weird, right? So minimum and maximum becomes kind of like this. So this stays in here, and then they jump. Sometimes it's at like 420 even. Sometimes it's like at 420. Really interesting. What's funny is that this is inverted stuff. The Z's are 1 over Z's, are they? I think they are. So if I take a look, what do I say save in there? Right. So these are the Z's like that. I wonder if there's any NaNs. If I had any NaNs, would they go into min Z and max Z? That's an interesting question. I don't remember how NaN work. So I know that NaN has this like weird property that it's sort of like bigger or smaller something. So let me see. I remember that C has like isNaN function. IsNaN. Why is it in Russian? Like, just give me CPP references. Oh my god. Google is so dumb. It's insane. I'm sorry. It's just like, it's a multi-billion-dollar corporation that has all of my data. Like, it knows everything about me, yet it gives me absolutely irrelevant results. Like, why do you have so much money? Why do you have so much data about me if you cannot give a valuable service? It's just like, I don't understand. Why the fuck? That's what infuriates me so much, right? I would understand this kind of like quality of the service if I gave nothing to Google, but I give a lot, right? So actually, and anyway, so we need to import the math. So I think we already have the math, and it's just isNaN, right? So this is true. Infinity is not none, right? But maybe not. Okay, so let's do something like boolean contains none, and this is going to be something like false, right? And if z buffer I is none, we're going to just set this entire thing to true. And if contains none, printf contains none. I think it would actually show up. I'm pretty sure the properties of the comparison of none set up so they will show up in minimum and maximum. I have the feeling that's the reason why they're set up like this. Yeah, that's very interesting. Huh, okay, well, just a second. Does not contain, does not contain none. Okay, so let me see. Does not contain. Okay. does not contain none, so it's actually kind of cool. So none of that weird bugs result in this thing containing none. So this gives me like a very interesting idea. Just a second. I really want to test it out regarding none. Right. stdio, and maybe this is going to be main. Return. So how can you get none? I think the easiest way to get none is just like divide by 0. 0 divide by 0, and you straight up get the none. Right, so we can even test it out like so. Right. So I'm gonna do clang o foo c, and I'm just gonna run the foo. Okay, so as you can see, it is none. Right, we can do something like this. If x is less than 69, we can print f less. If x is greater, if x is equal. Right, so how many of those are going to be printed? So that's a very interesting question. Okay, none of them were printed. Right, none of them were printed. So that means all of that is false, right? So that means if we have any none in here, it's not gonna appear neither in minimum or in maximum, right? Because none of these results are gonna be true, so it's sort of like ignored. Which is fine. So that means this sort of condition is necessary for me, right? So if there was a none, I wouldn't see that neither in minimums, not in maximums. All right, so that's pretty cool. So that's very interesting. I kind of want to actually rename these values. I think this is not a minimum z, it's a minimum inverted z. You know what I mean? Because it's not like the actual z value, and that's quite important to remember. A max inverted z, right? So this is a max inverted z. Because I would like to also just see what is not inverted versions for the z. So if we invert them back, right, if we invert them back, what do we get? Right, what are the values? So okay, so this is the wrong thing in here. No such thing, and let me just see. Okay, I actually want to go into the normal mode and just see what's going on, and we get infinity. Okay, so because of some values containing 0, we might sometime get infinity, and that may mess up some of the computations. Okay, so that's already interesting. All right, so if I go in here and do stats, all right, so some of this stuff actually like works out, right? So this is like a 0, max 1, so, and we can just like see that it is like that, okay, so that is really interesting. That is really interesting, but maybe all of that has something to do with the fact that we probably should interpolate. So maybe it has something to do with this kind of fact, because we sort of like moved it further, right? We moved it further, but maybe when we're actually interpolating things, we have to move them back, right? We should maybe try to move it back. But this +1 is really needed for the projection, right? Because otherwise this specific projection is not going to work. Or I think rather this one, right? Because otherwise it's just not going to work out. So, yeah. That's something that we need to do. But unfortunately, I would like to make a small break before I go and just try to experiment with these things. And I want to make a cup of tea, right? So let's make a small break. So, let's try to understand what the hell is going on with our lives, right? So essentially, somebody in the chat noticed that we are initializing everything with 0, right, with z buffer, and if you invert 0, that means everything there is infinitely far away. So I suppose those infinities, or those zeros, if you invert infinity, are coming from the background, right? So they're basically background, so which is actually a very good point. I wonder if maybe one of the things we want to do, we actually want to compare, right, to inverted values, right? So if we imagine that z is a straight up the z value, right? It's a straight up z value, and we don't care about anything else. So what do? We probably would compare it like this, right? So z is less or equal than 1, and z is less or equal than 2. Maybe not even equal, just in case, let's not make it equal. Right, but if z is actually inverted, like 1 over z, we probably want to invert these things as well, right? So we'll want to do this. 1 over 1 is going to stay 1, but then this thing is going to become this, so it's inverted, but it's less than 1, so maybe we're now actually checking this thing, right? So we're checking from 0.5 to 1, and that's the clipping stuff. And here is an interesting thing. Would it be too much? All right. Okay, let's actually try to do it like this, right? Let's try to see if this thing is greater than half, but smaller than 1, right? And if it is, right, if it is, we're gonna actually set it in there. Right. So maybe that will work out. We might as well do something like this. Maybe it has to be actually checked before this thing, right? Maybe it has to be checked before this thing. So first of all, we see if we are within the clipping planes. Then we see if we are sort of bigger than whatever we have in the z buffer, so that means we're closer. And in that case, we're authorizing a pixel to be rendered. So that's what we do. It's a pixel authorization. That's what it is. It's kind of funny how I made like a comparison of graphics, computer graphics and web, right? I said that the shaders are like server client applications, right? Shader is like a JavaScript, right? So when you visit a server loads up a code on your machine, that code starts executing, connects back to the server, and server and client start communicating, and this is a web application. It's kind of similar with the shaders, right? So you run a program, your program loads a shader on the GPU, GPU connects back to the CPU, and they start communicating, and this is the graphical application, right? And here we have, basic pixel authorization. This is such a cursed comparison. Holy shit, I love it. So soon we'll be writing microservices, right? Yes, that's exactly what we're doing. So, is it not bog? Is it not bog? I think it's pretty freaking bog. Okay, so I'm a little bit nervous if this is going to... You know what? This shit worked out, kind of. If you think about it. There is kind of weird stuff in here, which I do not fully understand why the fuck it is happening. Right, I still do not understand this stuff. So we have things from 0 to like half in here, and of course there's infinity, but yeah. Yeah, like I don't understand why this happens. So, do you have a computer science degree? With your skills you could easily get PhD. Isn't PhD like a philosophy doctor? What PhD stands for? Doctor of Philosophy. Do you know what is a philosophy? You think I'm doing a freaking philosophy in here? You think this is a philosophy? Furthermore, I'm not a doctor, I'm not, you know, treating people. I'm not curing diseases, especially in the field of philosophy. What kind of bullshit is this title? What? Excuse me, no. I'm a programmer. I'm solving technical problems. I'm not curing people in the field of philosophy. I'm not doing any of that bullshit, okay? It has nothing to do with philosophy. Yeah, everything I do has nothing to do with philosophy. I do agree with that, and that's why I don't have PhD. All right. Are you authorizing the pixel or vertex of a triangle, specifically pixel? Because here I'm iterating all of the pixels of the triangle, right? So first of all, I'm iterating all of the pixels of the rectangular boundary, right? Then I check if the pixel within the boundary is within the triangle, right? Then I calculate how far it is from the vertices of the triangle. So then I can interpolate the z-values. And once I interpolated z-values, I got the z-values, and now I kind of know what is going on, right? So now I can work with that. All right, so okay, that's kind of cool. We kind of implemented the far and near clipping plane. I'm kind of proud of ourselves because this is precisely what I wanted, right? So isn't that cool? I think it's pretty cool. We can clearly see that like inside of the teapot. We can even see that it has some sort of like a thick wall in it, right? As you can see, there's like this kind of stuff. So you can clearly see this thick wall, and this is like sort of like below the lid. Right, so there's a lot of like inner things that are very interesting that we didn't see before, but yet when we hit the handle, or how is it called? Spout. I think it's called spout. Yeah, I think it's called spout. When we hit the handle or spout that are too far away behind our clipping plane, something goes nuts. Fucking nuts. We can even see. Just a second. Yeah, like what the fuck is going on? Is that a spout? It kind of looks like, well, but not really. Is that, maybe this is what you have in a spout? Because who freaking knows? Like, yeah, look at that. Like, what the fuck is this? I don't know. Some crazy shit is happening at this point. Anyway, so maybe something weird is going on when we are projecting these values. So that's the problem. I don't know, I've never seen inside the pot. Yeah, exactly. So maybe that's how pot from the inside is supposed to look like. Who knows? Maybe our mental image of the spout is wrong. Yeah, this is how real developers fix the bugs. They start to gaslight and question the reality itself until everyone believes that there is no bug in there. So anyway, I want to actually try this kind of stuff with the cup, right? So gaslight the reality. So imagine gaslighting the reality itself. Alright. I need to find the assets. Assets. Right, where do we build the assets? So this is where we build the assets, and I want to make the cup a bit bigger. Right, so this is gonna be S, and we can make it like this, just a little bit bigger. Cup3d, Cup3d, and I'm gonna put it in here. So yeah, look at that. That's precisely what I want. That kind of works perfectly with the Cup3d. Look at that. Look at it go. Hell yeah, brother. Look at that, motherfucker. Maybe it has something to do when these, like, the vertex becomes sort of negative. Maybe that's when the shit hits the fan. But yeah, so clipping in here kind of works. I wonder if I make it like twice as big, right? So we're literally inside of this thing. For the teapot, yes. Well, I mean, there's some glitches here and there, but overall, I wouldn't say that it's that bad. So what about if we make it like 4 times as big? So I want to make it really big, so majority of the things are going to be like clipped anyway. Okay. Alright, so let's go back to the Utah Teapot. One of the things I want to test with the Utah Teapot, Teapot3d. Teapot3d. I'm going to make it just a tiny bit smaller. Alright, so it works. Let's make it 5. So I want the spout to clip, but only like a tiny bit of it. Yeah, there should be no such weird bugs. Why do we have such weird bugs? It's a mystery. It's truly a mystery for us. It is truly a mystery. Yeah. This is, by the way, the original size, so the clipping planes of... It's actually really cool. Yeah, if you look inside of the spout, we don't have any of this bullshit. I wonder if some of the weird stuff starts to happen when some of the points become like literally negative or something like that. You can see the spout goes inside of the pot. Yeah, you can, but that shouldn't cause any problems. It's actually kind of interesting. Like, I actually knew about that before. It's like part of the model, right? The spout actually goes inside of it. It's just like clipped into that. So that's actually pretty cool. We rarely see this teapot from the inside. Man, the clipping plane works so fucking cool. And what I like about clipping like that is that since we work on the level of pixels, it just works automatically, right? It just works automatically. You don't have to do any weird geometry or anything like that. It's just like, yeah, it works automatically. So that's kind of cool. But let's actually try to imagine what's going to happen if one of the z's become negative, right? One of the z's become negative. What is going to happen? All right. So we do +1, but it ends up to be negative anyway. All right. So here is the 3D to 2D. In here, we will divide x and y by a negative value, which will make this entire thing negative as well, right? Which will make this entire thing negative as well. Okay, so after that, here's the screen, and these things are negative, and we're projecting them onto here, and we may end up with things that are like way outside somewhere there, right? Way outside there. And which may result in something really weird eventually. Yeah, I have a feeling that basically this kind of shit happens when some of the z's are literally negative, right? We can maybe even test that, right? v1z greater or equal than 0. v2z, v3z. Okay, so we don't have assert. Let me actually quickly include assert. Okay, so as you can see here, none of them becoming negative, so everything's fine, which is nice. All right. So, and we're asserting specifically the already... No. Maybe... I was thinking that we already asserting projected values, but projected values don't have z's at all. Okay, let's actually keep it like that. Let's now go to the build script, and let's start making this entire thing a bit bigger. Okay, and this shit started to happen literally when the spout went towards us. And okay, so I'm gonna actually disable the assert. Maybe I'm gonna actually make the assert so it just spams in the chat, not in the chat, but in the log. Right, so let's actually put something like if, right, if this thing is less than 0, which is rather interesting. So z should not be equal to 0, by the way. Right, because we're dividing by z, so that's quite important. And you can't divide by the negative value, otherwise you're gonna have a really bad time. Right, so printf and alarm. Yeah, something like this. Let's put it something. Well, I mean, it's kind of becoming already obvious what's going on in here, right? So it's kind of becoming already obvious. It's kind of funny, isn't it, when as soon as we start... Okay, how can you hear me? We back, two back. All right. Okay, let's give it a try. I think. Oh. 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 Okay, so that's cool. How can we fix this shit? Because this is kind of an interesting question. Right, this is kind of... I don't fucking know how we're gonna fix that. But at least we already know the root cause, right? The root cause. Let's imagine the situation. I want to redraw this entire thing one more time. Let me actually pick this stuff. And there we go. So this is going to be Z, this is Y, and this is I. This is 1, which is the screen. Screen. So this is 2, this is a far click and play. Imagine that we have a triangle, the Z value, the Z value of which is negative, right? So one of the things like goes away, and it goes like this, right? It kind of goes like this, and this is something that I was afraid of that we'll have to do. So essentially, sucks. This sucks so much. Essentially, how can we render? Because we should avoid even touching like these things, right? We should avoid even touching these things. So we need to split this triangle into this stuff, right? And now we have to split this into 2 separate triangles or something like that. Yeah, like this. And draw them separately. You know what I mean? Because if one of the vertices of the triangle goes below 0, we can't just, you know, throw away the entire triangle. We can't just throw away it, right? Because it could be still visible, right? Just because one of the vertex kind of touches this entire thing. Right, so we have to really handle this entire shit geometrically. We really have to handle this shit geometrically. And since we're kind of going into the business of handling the shit geometrically, why can't we just do that right here, right? So, like, why not just do it right here and just throw away this entire thing and just, like, draw it like this then? So, if we're gonna go into that business of things. But it feels like this is something that we have to do, right? So it feels like this is something we have to do, otherwise we're gonna get this kind of stuff, right? How will we handle the rainbow texture when it's two triangles? So you just interpolate, right? So when you know this point, you know how, you know its barycentric coordinates, right? So usually by rainbow texture, you probably mean the color interpolation between the vertices, right? So essentially the way you make a rainbow triangle is that you associate each individual color, each individual vertex with a color. Then, while iterating through all of the points on the triangle, you calculate their barycentric coordinates, which tell you how close it is to each individual vertex, and you use the barycentric coordinates as weights to interpolate the colors between three colors, right? So you compute like the average of these three colors according to the weights of barycentric coordinates, right? So essentially, what you can do when you split it in three triangles, you can compute the resulting color for that specific vertex, and you can associate that color with that vertex in a new triangle, and you get the same result, right? So all of the information is in there. Is that what you mean? I suppose that's what you mean. Right. So yeah, but I'm still looking for something easier than that. I'm really hoping to find something easier. Alright, so how can we do that? We can effectively project this thing onto the screen, can we? We already are kind of computing the projection, and this is what we get. Right, we already are kind of computing the projection, and maybe this is what we have to do at the end of the day. Oh, not really. So essentially we have to pretend that this is the eye. But again, so we're starting to have a lot of like situation when it's kind of weird. You know what I mean? When it's kind of weird. Ideally, I would like to have something like this, where I could just put a single condition and it just works automatically. You know what I mean? Right. I just like want this thing to work out automatically. I think that will be kind of cool. So where is the no build? So this is no build. Where is the asset building? Asset building. So let's put 4 in here. Right. So if we do it like that, it just works out automatically without me doing anything. That will be kind of cool. What's interesting is that when z is negative, you end up with negative x and negative y in the projected space, right? Which is somewhere here in the left top. Even if the value has to be somewhere here, there. Right. What I'm thinking is that, what if I just say fuck it? And just do it like that. There we go. That's an interesting idea. So what kind of results are we gonna get? What kind of results? A second. This is actually not bad. We mirror in them. We mirror in them, and we get values on the screen. But when we're interpolating, we get negative values that we can use for clip, far and near clip stuff. This is kind of cool. You will be able to see stuff behind you. Exactly. But we can preserve the original Z values while we do the Z checking, which will end up cutting off or culling those pixels. But it will keep the projected coordinates, the screen projected coordinates, within the screen without causing negative, like blowing up. This is theory. This is at least theory. But this is an interesting idea. I like that idea. Okay, so there is a little bit of a problem with like 0 and stuff like that, but I'm not quite sure how to handle it. So essentially, I feel like this kind of stuff has to be done within the project 3D to 2D. You know what I mean? Somewhere here. So this exact math definitely breaks at z equals 0 because of this. But right now it definitely breaks even if it's negative. So let's actually test it whether it's negative or not. Let me try to do if v3z less than 0. Let's do v3z equal negative. Right, let's try to do that and see how much it changes. Alright, so this is without negative z's. You can't see that, but I mean, yeah. So this is without negative z's. So let's introduce some negative z's by making the teapot a bit bigger. Let's make it a bit bigger. There was a glimpse of something, but I suspect that that glimpse was because of 0 value. You see how it works out? It works out precisely because I keep negative values while interpolating. So yeah, I think we fixed it. Oh, okay, I'm sorry. Like, so here's the result. Man, I think we fixed it. Look at that. Look at this mother flipper. We fixed it. This is it. I think this is literally it. Or like that. Okay, so there's some problem with equals 0, but I mean it's not that often, so it's gonna end up with just infinity, and it's just like whatever, I suppose. At least here it doesn't really cause that much problem. What I wanted to do, I wanted to also do the following thing. So this is 1 over 1, right? This is 1 over 1, and this is 1 over 2. 1 over 2. So the reason why I'm doing that explicitly, right, so let's actually put it like this. So near is 1, far is 2. And I'm gonna like literally put them in here. So this is near, this is far. Near and far. What if I make this stuff a bit closer and this stuff a bit further? So now we can kind of control these things, can we? I think that's what we can do, chat. I think that's what we can do. Yo, that's super cool. I'm really happy that we're getting somewhere with this bug. Right, because it was kind of annoying, but I just didn't have time to address it. That sounds like Counter-Strike, where they basically build maps far removed from 000 because of the weird bugs. So I mean, it sounds good to me. I mean, why not? It's one solution. But another solution is to maybe just basically remap all of the coordinates. Like in some engines that are trying to make it comfortable for users, what they can do is that do all of the calculations actually far away from 0, 0, but store data close to 0, 0. You know what I mean? I mean, who said that you cannot? When doing all of the you know, tricky computations, you can just basically move everything far away from 0, 0, do all of the computations, and then bring it back when presented to the user. So you can do this kind of stuff. Why not? But I don't really know how like modern engines do that. I'm not an engine developer. I'm not a game developer. I'm not even a computer graphics developer. I doubt that I'm even a developer, to be fair. I'm just a shit poster on Twitch. Just reunit math so dividing by 0 doesn't break. You can probably do that, but you'll have to reinvent everything around that. Just a humble philosopher, exactly. Oh, that's why somebody was asking whether I have a philosophy degree or something, right? Imagine a computer scientist and getting a philosophy degree. And then calling yourself a doctor. Insanity. Literal insanity. Anyway. Is Biscuit still around? I don't know. I haven't followed his video lately. I hope he is. He's doing some cool shit. Has been doing at least. What am I doing, by the way? I forgot. Yeah, I want you to see what's gonna happen if we change the near and far. Yeah, that's what I wanted. Look at that. Oh, this is so satisfying. Look at that shit. Oh, this is such a cool demo. It, like, clipping, it works. It fucking works. You know what I want you to do, chat? I actually want the near clipping plane to be as close as possible so you can do some cool shit. Alright, let me see. I'm not in the model 3D. Okay, let's actually put this stuff like this is gonna be 3, and this one let's put like 1, 0, 1, and see how it's gonna work out. Yep. So you can be very close. So we saw some glitches, probably because of equal to 0. So I can show you. Well, it wasn't that glitchy, to be fair. Okay. Anyway, so the next thing I want to do, I want to make the teapot huge. Let's actually take its original size of 1. Right, let's keep it at 1. And we're inside of it. We're literally inside of this entire thing. Well, we can do something like 5 to make it even bigger. Just to see what's going on in there. Okay, so I think it's too big. Alright, so let's make it like 2. So one of the things I really want you to do is to just like make it so we can see insides of the thing. Okay, so we can try to control the near and far stuff. So let's actually make it 25, but make this thing a little bit too like a little, much further. Yeah, maybe we should actually disable shadow. Yeah, I think that's one of the things we can do. We should disable the shadowing. So the shadow is done in here. So let's go ahead and disable it just to see how it's gonna go. Yep. There we go. Needs a flashlight. Holy shit, okay. So there should be some sort of like a shadow, but I don't know, how to say that? It becomes too shadowy very quick, if you know what I mean. It becomes too shadowy very quick. And in here, we're doing -1, and maybe what we have to do... Yeah, so this is because it's too big. Alright, so we can do -1, and then we can divide by far clipping plane, interpolating that value yeah, interpolating that value far, so it can actually produce a better lighting or shadowing. So it's more of like a shadowing rather than lighting. Yeah, we can kind of control that, but it's kind of like difficult to look at, if you know what I mean. Right, so if I put 3 in here, so maybe it's gonna be a little better. Yeah. But it's kind of cool that we can see inside all this entire stuff, but at the same time it's kind of difficult to look at. Right. Alright, so we figured out what was the problem with this thing, right? And the only thing we needed to do in here is when we dividing and projecting is just to negate the z if it's negative, right? So what we're gonna do when z is equal to 0, right? So that's a very interesting question. So z is straight up equal to 0. What do we do about that? I don't know. So far, it doesn't really cause that many problems, right? So maybe I'm gonna actually leave it as it is, because like I don't have a like right away answer what to do when z is straight up equal to 0. Add a very small number, I guess. Maybe that's one of the things we can do. Handle situation when v3 z is equal to 0. When you put a very small value. Yeah, so essentially we can do something like this, v3z straight up equal to 0, right? Or maybe, let's put it this way, the absolute value, well, it's already absolute, we can keep it like that. It's smaller than a certain epsilon, right? It's smaller than a certain epsilon, and in that case, we can just add that epsilon. So, and we can just define this like epsilon 1 e minus 6. Is that a good idea? What do you guys think? I think that's a reasonable idea. It's like, yeah, sort of. And it's gonna be behind the near clipping plane anyway. So during the computation, it's gonna be cut off, right? So all of that is just needed for, I suppose, stability. So it doesn't produce the inf value of float, so it doesn't ruin all of the computations. I guess that's the reason why we want to do that. That kind of makes sense. So that's cool. So near, far, and now I want to bring back the original sort of values, right? So assets, so I don't remember what it was. So I kept the cup as it was, and the teapot was 0.04. Right, there we go. So this is 0.4. So this one, yeah, this doesn't have to be equals. Oh, right, so that's what we have. So did it actually cut a little bit? I think it did. Yeah. you can clearly see that it actually cuts. Yeah, this is inside of this thing. Right, so we probably have to make it a little bit closer. Right, so let's actually put like 1. Barycentric coordinates, yes, we're using barycentric coordinates. That's true. This is how we compute them. So, alright, so we probably don't need this key down stuff anymore. We can remove that. So none of that is important. Implement near far clipping plane. So there we go. That's pretty cool. Let me now go ahead and rebuild everything. Let's go ahead and rebuild everything. So I'm gonna keep the new way of doing things. So VC is not needed anymore. So the whole fix, surprisingly, well, this is not part of the fix. This was caught accidentally. The whole fix is, first of all, fix the projection 3D to 2D, right? So when z becomes negative, just, you know, make it positive, and if it's less than epsilon, just add a little bit of epsilon so it doesn't cause the division by 0 or something like that, right? And then just introduce a near and far clipping plane and compare them in inverted value. So here we also divide by 3, but this is to actually let the lighting to go further. So it was not in the original demo, so I think I'm gonna actually bring it back. So it's kind of cool. The original lighting is actually works better in my opinion because it goes further. Right. I think we can even... so this was division by 3, but what if I multiply this thing by 2, making the shadow even closer? So by modifying this thing, we can actually control how close the shadow is, so this thing is going to be a little bit more shadowy, if you know what I mean. We can multiply it by 4 now, so it becomes even more interesting. Well, it actually makes kind of a sharp edges for the shadow. So what I'm trying to do, actually trying to bring it close. I wonder if I can do that good enough. Something non-linear is happening in here, so I'm not gonna play with that anymore. I think the original shadow was fine. Okay, so, and this is basically the entire fix. I'm actually surprised. So I guess the main problem was like with this stuff. Okay, and it's cool that we actually understood the problem. Alright, so let me go ahead and like rebuild the entire stuff, like everything, from scratch. Oh shit, fuck, damn, I forgot that I don't have assert in WebAssembly. Right, so when we're compiling to WebAssembly, we don't have libc, right? So anything from libc is just not gonna work there. Does olibc have quaternions for rotation? No. It doesn't have a 3D. 3D is implemented outside of olibc. So, but I think I'm starting to think how to move some of the 3D stuff inside of olibc so it's available for everyone. Okay, so let me now maybe run some tests. Let's actually run some tests. Tests. Run. Okay. Okay, so I actually want to refresh the cache as well. So let's do Control R just in case. Alright. Seems to be working. Seems to be working. Ooh, that's a big cup. I mean, what caused the cup to be so huge? Because I set the scale of the cup to 1. Okay, that's very interesting. So it should not affect the scaling. That is really weird. Alright, so let's rebuild now the demo then. No build, demos, Cup3d, actually all of the things, all of the platforms. WASM terminal and SDL. What changed though? Okay, it copied it. Is that because of what we changed? I can't believe that. What if I run some other things? Red build, demo, Cup3d, SDL? Yeah. Is that really because of the things we changed? I don't think we changed that much, do we? Okay, what if I stash that stuff and I rebuild this thing one more time? And then I run the cup one more time. it is still big. What is going on? It wasn't this big before. Magic. Always has been. I don't think so. But we can always just make it, you know. This is not what I want. Okay, so I'm remove that. Did I just lose? Okay, so I just lost all of the changes. Well, kind of. Alright, I still have them saved. Yeah, I still have them saved. I didn't lose them, I have them saved in the buffer, so everything's fine. Close call, yeah, exactly, that was close call. Yeah, so let's actually commit everything very quick, so we don't forget. Implement near for clipping planes. Implement near for clipping planes for model 3D demos. And we push that right into the room. We didn't have, yes, everything seems to be fine. Everything seems to be fine. But the fact that it just looks different now is so sus. Because if I just go and like literally go one commit before and rebuild the demo Cup3d, I'm pretty sure it wasn't that big before. Am I tripping? I remember it was way smaller. Okay. Let's take a look at the build process in here. Okay, so everything is built correctly. This is probably because we need to regenerate the assets. That's right, I forgot to regenerate the assets. That's what happened. And if now I rebuild the demo, of course. That's why you have to use makefiles, right? Yeah, there we go. So that's the original size I was hoping for. That's the original size. Cool. So let me go back. How do you go back? I want to do master. I'm going to rebuild everything. So it also rebuilds the stuff. Okay, so we're already streaming for 2 hours, I suppose, so maybe I'm gonna call it a day. So today was rather productive stream. We implemented the far near clipping planes, right? And it worked out exactly as I wanted to work out, so I'm super happy about this entire stuff. I'm super happy. Is there a function in no build script that recompiles everything, generating assets too? Yes, I just ran it and it just worked. Okay, so that's it for today, boys and girls. That's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all next time. I'm gonna do something else, I suppose. All right, love you. Mwah.